morning, cadets. Now we'll see the second type of the clutch. In construction and working of the clutches, we already have seen the first type of the clutch, that is single plate clutch. Now we'll move to the second type, which is called as a multi-plate clutch. Okay. So let us go to the slide of the multi-plate clutch. Okay, this is the multi-plate clutch. Now, as the name suggests, there will be the multiple number of the plates. In single plate clutch, there was only one plate, friction plate with the friction material. Here, there will be a number of the clutch plates with the friction materials. Okay, so it is same as the single plate clutch, but there are two or more clutch plates are inserted between the flywheel and pressure plate. This clutch is compact than the single plate clutch for same transmission of the torque. So instead of using the large radial or large radius one plate, the number of the small radius plates are used. So the torque will be increased by increasing the number of the plate instead of increasing radius. So when the space is small, we'll be using n number of the plates with the friction material, so the torque will be increased by increasing the friction area with increasing number of the plates. So it is used in the small space like in the motorcycles. So single plate clutch is used in cars, trucks, etc., and multi-plate is used in scooters or motorcycles. Let us move to see the construction and working of this. So here you can see this is again an engine shaft to which this flywheel is attached. Okay, this is again on this side there will be a pressure plate. So pressure plate and flywheel are bolted. So this whole assembly will be rotating together. And these are the clutch plates we have. 3 clutch plates you can see, and in between there are another plates which are inserted, that is generally steel plates or the cast iron plates which are inserted between, so that the two friction plates should not come in contact. Okay, so to avoid the contact of the two friction plates directly, the alternate plate which is inserted between the two friction plates to avoid the wear or slipping or the heat produced, and so that the torque can be transmitted continuously. For that purpose, the steel plates or cast iron plates which are always inserted between the two alternate clutch plates. Okay, other assembly is very similar to the single plate clutch. Only difference is that there are more number of the plates which are used. Now we can see in the next this. Okay, this diagram we can now refer. It is very similar. It is again the drive coming from the engine. So this is the driver shaft. Okay, this is the pressure plate. This is the last plate, which is the pressure plate. This red one, this inner plates are the clutch plates with the friction material. These are your alternate steel discs. It may be sometimes a cast iron discs which are avoiding the direct contact between the two alternate clutch plates. This is again a compression spring which is using its property of the elasticity or stiffness to cause these clutch plates to move towards and away from the flywheel during engagement and disengagement. Okay, this cover is called as a clutch cover, inside which this whole assembly of the clutch plate and pressure plate and steel plate is there. It is also called as a basket. Okay, and finally the drive is given to the transmission. So this is a clutch shaft or the gearbox shaft which is finally providing power or the motion to the wheels. This is again a clutch plate, clutch plater. When it is pressed, whole this assembly will move back away from the flywheel, and the power transmission from the engine to flywheel will be stopped to the clutch plates and finally to the transmission shaft. So this is a simple construction having the n number of the plates. Okay, this is the elaborated picture of the same diagram. Here you can see these are the clutch plates, and in between there are the steel plates. Now here we can see more elaborated picture. This is a flywheel which is attached to the engine shaft or the driver shaft. This is the clutch plate. These are the clutch plates we have. Okay, these are the clutch plates, and this last one is a pressure plate. Okay, and the steel plates are used in between. Steel plates are used in between so that the power, when transmit from the drive shaft to the driven shaft, this whole assembly will be moving together or transmitting the power together, or disengagement happens when the flywheel will be detached from this. This clutch cover is directly bolted to the flywheel. Now we can see how these steel plates are and the clutch plates are held together. You can see for this steel plates, this is the upper slot. For this steel plate there is upper slot. Okay, and there is a same slot inside this clutch cover, that is the inner slot. So this upper slot will be fixing in the clutch cover or the clutch basket. Okay, and these clutch plates, you can see there are the inner slots. So this inner slot will be fixed on the spline shaft. The spline shaft is the shaft which is of the gearbox, or it may be a clutch shaft. So simply the steel plate are held fixed with the help of the slots of cover, and the clutch plates are held fixed on the spline shaft by these inner slots or the splines, you can say inner splines, and this will have the outer spline, so that all this will be held together. Okay, and whenever the foot pedal is pressed, whole this assembly is moving away from the flywheel, so that the power transmission from the flywheel to the clutch shaft will be stopped. Okay, so this is simple construction and working of the multiplate clutch. Same is written here in detail, you can read it. I already have discussed this. What are the parts? Clutch basket or a cover, clutch hub. Clutch hub is a spline hub. Drive plates, which are the clutch plates with the friction material. Driven plates are the steel plates which are inserted between the two alternate friction plates. Pressure plate is the one plate which is the last plate directly attached to the clutch cover. And clutch springs, which are operating this pressure plate by operating the diaphragm spring, as what we have discussed in the single plate. This can be seen in the picture. Okay, the working is explained here in detail. So working is detailed, given here. Multiplate clutches are used widely in motorcycle and scooters, as I said, because there is a very small space available. So this is becoming the application of the multiplate clutch. Okay, so multiplate clutch, for the knowledge purpose I have given n number of the slides for the same construction and working. You have to make a notes of your own. You have to focus just on the basic construction and working of the multiplate clutch. Okay, now we'll move to the next type of the clutch, which is called as a cone clutch. Okay, so this is the third type of the clutch, cone clutch. As the name suggests, there will be a cone shaped disc. There are not circular discs as we have used in single plate and multiplate clutch. A cone clutch has the same purpose as a disc of the plate clutch. However, instead of mating two spinning discs, the cone clutch uses two conical surfaces. That is the difference. Okay, conical surfaces to transmit the torque by the friction. There are no spinning discs, but there is a conical surface. The cone clutch transfers higher torque than the plate clutches and increased surface area. Cone clutches are generally now only used in low peripheral speed applications, although they were once common in automobiles and other combustion engine transmission. So there is very limited use of the cone clutch now. It is not used practically in the combustion engines because of the complications of the conical shape that we'll see in the later PPT. Okay, now this is the simple construction. It is very similar, only difference is that the two cones comes in picture instead of discs. This is the driving shaft. This is the outer cone, which is also called as the male cone. This is the inner cone, which is the smaller cone. This is also called as a female cone. The friction material is provided between the two cones, and the power is transmitted from engine to one cone to another, and again these springs will be providing the same action as that of the other clutches. Okay, this is how you can see the construction. It is the outer cone which is male cone, this is the inner cone, this is the friction material provided on that, this is the spring which provides the action so that these two conical surfaces come in contact for transmission of power, and when clutch pedal is pressed the contact will be stopped so that power transmission will be stopped. So cone clutches are friction clutches, they are simple in construction and easy to disengage. However, driving and driven shaft must be perfectly coaxial. It consists of inner and outer cones. The outer cone is fastened to the driving shaft as we can see there, and the inner cone is free to slide axially on the driven shaft due to spline. So this is a inner cone which is placed on the spline shaft. A contact lever is used here instead of the foot pedal to cause it to disengage. Okay, due to wedging action between the conical surfaces, there is a considerable normal pressure and friction force with the small engaging force. Now, what is the disadvantage that now we'll discuss here? Disadvantage is, see this, the semi-cone angle alpha is kept greater. Now, these are the cone shapes. We know in the cone there is an angle formed which is called as a semi-cone angle, that is generally expressed by alpha. This alpha is kept greater than a certain value. So whenever the operation takes place, the alpha should be greater than a certain value which is approximately 12.5 to 20 degree. So if it is greater than this value, then and then the self engagement will be avoided. If the value of the semi cone angle or the semi vertical angle of the cone is less than this certain minimum value, the direct self engagement takes place. So in that case, disengagement of the clutch become very difficult. So this becomes the disadvantage due to the conical shape construction. So because of the construction of the conical shape itself, that's why it is always difficult to maintain this situation. So that's why the cone clutch have a limited use these days. Practically it is obsolete only in some racing cars, etc., where or in some of the components where the low peripheral velocity is required, it is used. Okay, so same thing is expressed here. Cone, same figures are given in the different manner. Okay, so this you can read for the cone clutch. Advantages and disadvantages are explained here, which are already explained in the figure itself. Then we'll move to the last clutch, that is a centrifugal clutch. Okay, so let us move to the centrifugal clutch. This is the centrifugal clutch. This is the driving shaft which is attached to the engine, and this is the drum, larger or outer drum you can say, which is attached to the driven shaft. So power is transmitted from the driver shaft to driven shaft. So while engagement, the power is continuously while engagement of the clutch, we are stopping the power transmission from the driver to the driven, and for the continuous, when disengagement position is there, continuous power transmission from this driver to driven through the drum takes place. What the inner assembly is, it will have this shoe here. These are the 4 shoe you can see. So this is called as a shoe, and they are in attachment with the spider. These are the springs which are causing the centrifugal action. So this is a general assembly, and you can see each shoe is provided with the friction material. This is a friction lining. So whenever contact takes place, the torque transmission will be taken place due to the frictional force again. So from this we can now explain the further explanation. Okay, centrifugal clutch is a clutch that uses centrifugal force to connect two concentric shafts with driving shaft nested inside the driven shaft. It consists of the number of the shoe on the inside of a rim, as we have seen. The outer surface of pulley is covered with the friction material. These shoes are moved radially in guides. Okay. This clutch system employs centrifugal force to automatically engage the clutch when the engine RPM rises above threshold value. A centrifugal clutch is used in some vehicles, for example mopeds, also in other applications where the speed of engine defines the state of clutch, for example in chainsaw. Okay, so let us see the working of this. Right, here again the same diagram is shown. So whenever the speed of the driving shaft increases, this shoe will move outwards, okay, and it will come in contact to the drum, this outer drum, so that the torque will be transmitted. Okay, so when the speed is increased more, this will be hardly pressed against the drum, and so the power transmission takes place. Whenever the speed is low, the contact will not happen and the power transmission will be stopped. So here we don't have the other clutch member as in case of the single plate or multiplate clutch. Here speed itself act as a clutch member, means lesser is the speed. When the speed is less of the driver shaft, this shoe will not come in contact. When we increase the speed a little bit, this shoe will come in contact, so that the torque transmission will be taking place. At the highest speed, they will be hardly pressed against each other, so more torque will be transmitted. But when the speed is low, the power transmission doesn't take place from the driver shaft to the drum through the shoe with the friction material, and power is not then transmitted to the wheels. So speed itself, with the help of this principle of centrifugal force, is acting as a working parameter like clutch itself. Okay, so this is a working of the centrifugal clutch. Here same things are shown. When centrifugal clutch with the engine running at idle speed, so when speed is idle, this shoe will not go in contact with the outer drum, so power is not transmitting from the driver shaft to the driver shaft to the drum, and not to the driven shaft. But when centrifugal clutch at the operational speed will be like this, at the operational speed this spring action will be like this will get stretched due to the centrifugal force, and this shoe will come in contact with the drum, so power is transmitted from driver to the drum and to the driven shaft and to the wheels. Same is shown here. When the centrifugal force is strong enough to push the clutch, shoes hard press against the clutch housing like this. So because of the centrifugal action of the spring forces due to the speed of the driving shaft, the transmission takes place, or engagement or disengagement happens. That's why it is called as a centrifugal clutch. So this is simple working principle of centrifugal clutch. All are now covered. All four type of the clutches are covered. You have to concentrate only on the construction and working. Many slides I have given for the understanding purpose and knowledge purpose, out of which you have to read it properly, take notes of your own, and focus on construction and working. So clutch part is over. Thank you.